Diagonalization. The next one ma, diagonalizing a matrix. Diagonalizing a matrix means one matrix of order 3 by 3 or 2 by 2 are given. We need to diagonalize. That means we need to make that matrix as diagonal matrix. Already we discussed what is diagonal matrix. A square matrix is said to be diagonal if except the principal diagonal remaining all elements are 0. We can get that type of matrix, then matrix is diagonalized. For diagonalization, to diagonalize a matrix A, to diagonalize a matrix A, that should exist an invertible matrix. There exist invertible matrix P, invertible matrix P, such that P inverse AP equal to D. D is diagonal matrix, where this P is called modal matrix. This D is called spectral matrix, spectral or diagonal matrix. So this is the procedure to find diagonalize a matrix. To diagonalize a matrix, there should exist an invertible matrix P. Then if you can calculate P inverse, AP will be diagonal matrix, that is a spectral matrix of given matrix, that we need to find. So for diagonalize, what is the procedure we are going to follow? For diagonalize a matrix, I am discussing procedure now. For diagonalize matrix, let A be the given matrix. For example, A be the given matrix given to diagonalize. Then find eigenvalues and eigenvectors. Eigenvalues and eigenvectors of A. You know how to find eigenvalues and eigenvectors of A. Just now we discussed it like that. After eigenvectors means, you know, generally we represent eigenvectors with x1, x2, x3. Eigenvalues with lambda 1, lambda 2, lambda 3. That 2 you need to calculate. After finding eigenvectors, write matrix P or write modal matrix. Write modal matrix. Modal matrix P. Write modal matrix. I said modal matrix means P. P is nothing. Simply write eigenvectors as its columns. Modal matrix is a matrix which is having eigenvectors as its columns. That is modal matrix. Next, find P inverse using a formula. P inverse formula, adjoint P by det P. Using adjoint P by det P formula, find P inverse. Next, calculate P inverse AP, which gives a diagonal matrix. P inverse AP equal to D. Up to here we need to calculate. So if you know finding eigenvalues and eigenvector of a matrix, diagonalization is nothing. Because in diagonalization also we are not doing anything more. Simply we are finding eigenvalues and eigenvectors. That eigenvectors only we are writing as columns to write modal matrix P. So after writing P, we are calculating P inverse using a adjoint P by det P, or we can use calculator also. I will tell you calci operations for calculating inverse and det, everything, solving the equation, everything. I will give you complete calculator operations also. Next, find out P inverse AP, you will get D. This is the procedure to diagonalize a matrix. We will discuss one problem on diagonalization so that you can understand how to diagonalize. So now I am going to diagonalize matrix A. To diagonalize matrix A, first we need to write characteristic equation. Characteristic equation of A. Det A minus lambda I equal to 0. So diagonal, in the diagonal you need to subtract lambda. 1 minus lambda, 1, 1, 0, 2 minus lambda, 1, minus 4, 4, 3 minus lambda equal to 0. Now, characteristic equation I said one small technique. That technique I am going to use. Minus lambda cube plus sum of diagonal elements we need to write Sum of diagonal elements. Add the 3 elements. 3 plus 2 5, 5 plus 1 6. 6 lambda square minus sum of cofactors. Just now I said how to calculate sum of cofactors for the principal diagonal. Principal diagonal cofactor sum, you need to write lambda coefficient. For that, first one cofactor, if you remove first row and first column, 1, 1, 2, 1, 4, 3, sorry, 2, 1, 4, 3. If you remove first row and first column, 2 3s are 6, 6 minus 4, 2. For 2, second row, second column you need to eliminate second row, second column if you eliminate 1, 1 minus 4, 3 you will get. Second row, second column. So now 1 3s are 3, 3 plus 4, 7. Last 3. Last row and last column we need to eliminate If you eliminate last row, last column, 1 1 0 2, 1 2 0 2. Add 7 plus 4. What you will get? 11. 11 lambda plus det A required. Det A I said how to calculate. 1 into det A. 1 into 1 cofactor already we are having 1 into 2 plus minus plus minus 1 into minus 1 corresponding column row is eliminated 0 plus 4 you will get plus 1 into 1 corresponding column row is eliminated 4 plus 8 we will get. Last row first column 0 minus into minus plus 4 2 is 8. Okay. 2 minus 4 plus 8. 10 minus 4 6. Next we need to calculate lambda values. We need to solve this equation using synthetic division. I said synthetic division write coefficients minus 1 6 minus 11 6. Right. I said one technique to decide lambda equal to 1 is factor or not. What is the technique? Simply add these 4. If you get 0, lambda equal to 1 is definitely factor, then you can keep here 0 if it is factor. 6 plus 6 12. Minus 1 minus 11 minus 12. So 12 minus 12 0. So definitely lambda equal to 1 is root. Now write here 0 minus 1 plus 0 minus 1 minus 1 into 1 minus 1 6 minus 1 5. 5 1 are 5 minus 11 plus 5 minus 6 minus 6 into 1 minus 6. That becomes 0. Now factors are lambda minus 1 minus lambda square plus 5 lambda minus 6. If you take minus common here, lambda square minus 5 lambda plus 6 equal to 0, which can be written like this one. So 6 can be written as 2 3s are 2 plus 3 5. That's why the factors for this equation here are lambda minus 2 lambda minus 3. So finally eigenvalues we can decide here. Eigenvalues are 1 2 3. Eigenvalues are 1 2 3. Next we need to find eigenvectors corresponding to lambda equal to 1, lambda equal to 2, lambda equal to 3. First eigenvector. Eigenvector corresponding to lambda 1 equal to 1. Eigenvector corresponding to lambda 1 equal to 1. That means For first eigenvalue I am going to find eigenvector ma, that is a minus lambda 1 into I into x1 equal to O. That is subtract 1 from the diagonal. Subtract 1 from the diagonal. If you subtract 1 from the diagonal, 0, 1, 1, 0, 2 minus 1, 1, 1, minus 4, 4, 3 minus 1, 2 more. x1, x2, x3 next. x1, x2, x3 equal to 0, 0, 0. Now, second element to second element we need to write ma. As I said, one technique to find eigenvector. But if you write here, because these two rows are same, if you write also you will get 3 zeros. If you want you can check. 1 minus 1 0, 0 minus 0 0. That's why you need to change the rows. Instead of taking first two rows, take next two rows. That means second row and third row I am taking from second row, second element. 1 1 0 1. Here 4 2 minus 4 4. x1 by x2 by x3 by x1 by 2 minus 4 minus 2. x3 by minus 4 minus 0 minus 4. Yeah. x2 by 1 into minus 4 minus 4, 2 into 0 0. x2 by x3 by 0 into 4 0 plus 4. Now cancel with 2 mark. If you cancel you will get first eigenvector like this mark. 2 1 or cancel with minus 2 also to avoid 2 minus. Minus 2 into 1. Minus 2 into 2. Minus 2, if you cancel with minus 2, what you will get? Minus 2. So if you take minus k common also, you will get like this. 1, 2, minus 2 is first eigenvector. Coming to the second eigenvector, eigenvector corresponding to lambda 2 equal to 2. That means you need to subtract 2 from the diagonal. 2 from the diagonal. Subtract 2 from the diagonal. 1 minus 2 minus 1 1 1 0 0 1 minus 4 4 3 minus 2 1 x1 x2 x3 equal to 0 0 0. Now write second element to second element ma. Write second element to second element. Second element 1 1 minus 1 1 0 1 0 0. So x1 x2 x3. x1 by 1 minus 0 1 equal to x2 by 0 plus 1. x3 by 0 0 minus 1 into 0 0 1 into 0 0 0. So the second eigenvector you will get k 1 1 0. These two are two eigenvectors. Next we need to find third eigenvector, eigenvector 3. Eigenvector 3 we need to calculate. Eigenvector corresponding to lambda 3 equal to 3 ma. So simply subtract 3 from the diagonal ma. 1 minus 3 minus 2 1 1 0 2 minus 3 minus 1 1 minus 4 4 3 minus 3 0. Now here x1 x2 x3, right hand side you will have 0 0 0. Now write from second element to second element as usual. 1 1 minus 2 1 minus 1 1 0 minus 1. This is x1, this is x2, this is x3 ma. x1 by 1 plus 1 2, x2 by 0 plus 2, x3 by 2 minus 0 2. So all 2's we can cancel with 2. So the third eigenvector will be 3 ones. 200, 200, 200. Now we need to write model matrix P. P is x1, x2, x3. We need to write as columns 3 eigenvectors. So first eigenvector we all know. First eigenvector is 1, 2, 2. Just now we calculated. First eigenvector 1, 2, 2. Second eigenvector 1, 1, 0. Third eigenvector 3 ones. Next we need to calculate P inverse. P inverse formula you know, adjoint P by det P. So det P value we can calculate minus 1. That's why P inverse value for this matrix is minus 1, 1, 0. P inverse for this 4, 3, minus 1, minus 2, 2, 1. Minus 2, 2, 1. Okay this can be calculated easily by using calculator. I will tell you how to calculate P inverse, det P, everything. Calci operations I will give you one class completely. P inverse value. Next find out P inverse AP. That means write P inverse minus 1, 1, 0, 4, 3, minus 1, minus 2, 2, 1, and A matrix A matrix 1, 1, 1, 0, 2, 1, minus 4, 4, 3. Next write P matrix. P matrix we are having here 1, 1, 2, 1, 1, 2, 0, 1. So if you evaluate, if you multiply these three, no need to multiply actually, because the diagonal matrix which we are going to get is nothing. In that we will have diagonal non-zero elements. The diagonal non-zero elements are nothing. They are eigenvalues only. Eigenvalues are 1, 2, 3. That eigenvalues only we are going to write in the diagonal. This will be the diagonal matrix. For every problem, no need to multiply these three. If you multiply, it will take much time. Answer is decided at eigenvalues level only. Final answer, you will get eigenvalues in the diagonal. Because we got eigenvalues 1, 2, 3 like that, we got D matrix. For example, if you have eigenvalues 2, 3, 5, what you will get? 2, 0, 0, 0, 3, 0, 0, 0, 5 you will get. If you have eigenvalues 1, 2, 4, 1, 0, 0, 0, 2, 0, 0, 0, 4. Like that, if you have eigenvalues, that eigenvalues only you need to keep in the diagonal. This is called diagonalization of a matrix. Diagonalizing matrix. Matrix will be given like this. Finally, we need to get a matrix in which, except the principal diagonal, remaining all elements 0. Clear, ma? So next, we are going to diagonalize the matrix by using orthogonal reduction. In the previous problem, we diagonalize matrix simply. Then we don't have this word orthogonalization technique. Now I am going to diagonalize the matrix using orthogonalization technique. The difference between previous one and this one is, here we are going to make P matrix as orthogonal matrix. Whenever P is orthogonal, then P transpose will be equal to P inverse. What I am saying is, in the previous case we evaluated P inverse. Here instead of calculating P inverse, we are going to find P transpose. For that, same procedure. First, write characteristic equation of A. Characteristic equation of A, which is det A minus lambda I equal to 0. So subtract lambda from the diagonal. 1 minus lambda, 0, 0, 0, 3 minus lambda, minus 1, 0, minus 1, 3 minus lambda equal to 0. Next, we need to find characteristic equation. To find characteristic equation, we know one small shortcut. Using that, we can easily calculate the determinant of this matrix. That is minus lambda cube, sum of diagonal elements, sum of diagonal elements into lambda square minus sum of cofactors of principal diagonal into lambda plus det A equal to 0. So this technique, if you apply, you can get characteristic equation very accurately. So that's why I am taking help of this shortcut minus lambda cube plus sum of diagonal elements. You know, these three are diagonal elements. We need to add the 3. 3 plus 3, 6. 6 plus 1, 7 lambda square. Next, we need to calculate sum of cofactors of principal diagonal. For principal diagonal, we need to calculate cofactors. Here, principal diagonal elements are 1, 3, 3. For the 3 elements, we need to calculate cofactors. First for 1. So the cofactor of 1 is evaluated by deleting corresponding row, corresponding column. First row, first column is deleted. The remaining matrix what we are having 3, minus 1, minus 1, 3. Here you need to calculate det AD minus BC technique. This is A, B, C, D. 3 3s are 9. 9 minus 1, 8. Next, for next element 3, we need to calculate cofactor. Corresponding column, row is eliminated. That is second row, second column. Second row, second column is eliminated. What is remaining elements? 1, 0, 0, 3. Now find out AD minus BC technique 1 3s are 3, 3 minus 0, 3. Next, for the last principal diagonal element 3, we are going to find cofactor. Last row, last column is eliminated. What is the leftover terms we are having? 1, 0, 0, 3. 1 3s are 3, 3 minus 0, 3. Now add these all. 8 plus 6, 14. The 14 will be lambda coefficient, minus 14 lambda. Plus det A we need to calculate det A value. Det A value we can calculate very easily by using cofactor signs. Plus, minus, plus are the cofactor signs. Now I am going to calculate det A. Det A equal to 1 into 1 corresponding cofactor already we calculated that is 8. So 1 into 8 minus 0 into anything 0 plus 0 into anything 0. So no need to calculate cofactors for 0 and 0. So det A value is 1 into 8, 8. Det A is 8. Next, we are going to calculate lambda values. That lambda values only eigenvalues. To calculate lambda values, the technique we are following is synthetic division technique. Synthetic division means first write the coefficients of third degree equation. Coefficients: lambda cube coefficient minus 1, lambda square coefficient 7, lambda coefficient minus 14, constant 8. Now before going to search for the root, here we need to search for root. 1 may be root or minus 1 may be root or 2 may be root. Before that, one small technique to identify lambda equal to 1 is perfectly root or not. Simply add these all coefficients. So adding all coefficients means first add plus terms. 7 plus 8, 15. Next add negative terms, minus 14, minus 1, minus 15. 15 minus 15, you will get 0. If you get like that 0, lambda equal to 1, definitely factor. Definitely factor means, definitely root means, if you do this synthetic division process, at the end you have to get 0. The process I will tell you now. So lambda equal to 1. First write here 0, add these two, minus 1 plus 0, minus 1, minus 1 into 1, minus 1, 7 minus 1, 8, 8 into 1, 8, minus 14, you need to 7 minus 1, 7 minus 1 you will get 6, 6 into 1, 6 minus 14 plus 6, minus 8, minus 8 into 1, minus 8. 8 minus 8 becomes 0. Then lambda equal to 1 is 1 root. Next, remaining 2 roots we need to calculate like this. This is root. If you write like this, that is factor. Lambda minus 1. In lambda cube third degree equation, one coefficient becomes 0. That means you need to write from lambda square. That is minus lambda square plus 6 lambda minus 8 equal to 0. Now lambda minus 1 equal to 0, 1 root is 1. Coming to here, if you take minus common, you will get like this. Lambda square minus 6 lambda plus 8 equal to 0. These factors you know how to find. You need to find factors for 8 first. 4 2s are 8, 4 plus 2 6. That's why remaining 2 factors already decided 4 2. So 2 4. So finally eigenvalues for the given matrix are 1 2 4. 1 2 4 are eigenvalues of this matrix. Next we need to calculate eigenvectors corresponding to 3 eigenvalues one by one. So first eigenvector corresponding to lambda 1 equal to 1. Eigenvector corresponding to lambda 1 1. For that we need to solve a homogeneous system a minus lambda 1 into I equal into x1 equal to O. This one we need to solve a minus lambda 1 into I. A minus lambda 1 into I means nothing ma. In A matrix you need to subtract lambda 1 value. Lambda 1 is 1. So subtract in the diagonal 1. Copy remaining elements as it is. So 1 minus 1 0. Next two elements are 0. Next 0. 3 minus 1 2 minus 1. Next 0 minus 1. Subtract 1 from the diagonal ma. 3 minus 1 2. X1 is we don't know, unknowns. X1, X2, X3. Now we need to solve this one for non-zero solution. I said one technique to solve this one, easy technique to find X1. General procedure takes much time by applying row and column operation. For that what I said, simply by taking any two rows from the matrix, solve them, then you will get first eigenvector. Any two rows from second element to second element. First row all zeros, but never be eigenvector zero vector. Eigenvector never be a zero vector. That means if you solve any two equations, you cannot get three zeros. That's why avoid the zero row. So first row is zero row, I am avoiding. I am taking second row from second element to second element. 2 minus 1 0 2. Here also take from second element to second element minus 1 2 0 minus 1. Now using AD minus BC technique, this is x1 here, x2, x3. Using AD minus BC technique, simply evaluate x1, x2, x3 values. x1 by 2 2s are 4 minus, in the formula you will have minus, here 2 minus, minus into minus plus, plus 1. x2 by minus 1 into 0, 0, 2 into 0, 0 equal to x3 by 0 into minus 1, 0, 0 into 2, 0. So what you will get? 4 minus 1, 3, x2 by 0, x3 by 0. Like this you may get 2 zeros, but you should not get 3 zeros because eigenvector never be a zero vector. That you need to keep in our mind. Now you can cancel this one time, 3 1s are 3. So the final eigenvector will be like this. So final eigenvector, by assuming k we need to do like this. That's why I am writing k here 1 0 0. This is first eigenvector for the first eigenvalue lambda 1 equal to 1. Like this we need to calculate eigenvectors for lambda equal to 2, lambda equal to 4. Okay, so like this we are going to calculate eigenvectors for remaining eigenvectors also. Eigenvector corresponding to lambda 2 equal to 2. Again similar procedure how we done for the previous one. Like that we need to solve this homogeneous system for non-zero solution. Now subtract 2 from the diagonal. If we subtract 2 from the diagonal, 1 minus 2 minus 1 0 0 0. Subtract 2 from the diagonal, 3 minus 2 1 minus 1 0 minus 1 3 minus 2 1. x1 x2 x3 equal to 0 0 0. Again same procedure by writing any two rows from second element to second element. Any two rows from second element to second element 0 second element 0 minus 1 0. Here second element to second element 1 minus 1, 0, 1. 1 minus 1, 0, 1. Now x1, x2, x3. x1 by 0 minus 0, 0. x2 by 0 minus 1, minus 1. x3 by minus 1 minus 0, minus 1. So now the second eigenvector will be k into 0, minus 1, minus 1. Second eigenvector. Coming to the third eigenvector, lambda 3 equal to 4. That means you need to subtract 4 from the diagonal. 4 from the diagonal to solve this homogeneous system. A minus lambda 3 into x3 equal to 4. 1 minus 4 minus 3, 0, 0, 0. 3 minus 4 minus 1 minus 1, 0 minus 1. 3 minus 4 again minus 1. x1, x2, x3 equal to 0, 0, 0. Next, again we need to solve like this from second element to second element. 0, 0, minus 3, 0. Second element minus 1, 0, minus 1. So now x1, x2, x3. x1 by, here you will get 0 minus 0, 0. x2 by 0 minus 3. x3 by 3 minus 0. Minus into minus plus 3 minus 0. So x1 by, so now x1 by 0, x2 by minus 3, x3 by 3. Now cancel with 3 ma. x1 by 0, x2 by minus 1, x3 by 3 1 ja 1. So the third eigenvector you will get x3 equal to k 0 minus 1 1. This is third eigenvector. So now by using these three eigenvectors, we are going to normalize the matrix P because we are using now orthogonal reduction technique. In the previous problem, simply we written P as x1, x2, x3. But we are going to make P orthogonal. Orthogonal means instead of finding inverse, here we are going to find transpose. A matrix is said to be orthogonal, already we discussed. A square matrix is said to be orthogonal if A transpose equal to A inverse. That means if you make P matrix orthogonal, instead of finding P inverse, P transpose is enough. We need to make P normalized or orthogonal matrix whenever in the question if you have orthogonal reduction. But in the previous problem, you don't have orthogonal reduction. Simply diagonalize matrix A means you can write P matrix like this. x1, x2, x3. But now we are not going to write P matrix like this, we are going to write in different way. So now normalized P matrix we need to write. Normalized P. Normalized P is x1 by norm x1, x2 by norm x2, x3 by norm x3. So this is P. What is norm x1, norm x2, norm x3 we will discuss. Here x1 is 1, 0, 0. To write x1 by norm x1, you need to square all these three elements. 1 square plus 0 square plus 0 square. Square and add. 1 plus 0 plus 0, 1 you will get. 1 by root 1 is 1. That's why simply the same 1 you will get. x1 by norm x1. See here you will get the difference. Minus 1 square 1. Minus 1 square 1. So 0 by root of minus 1 square plus minus 1 square we need to write. That is norm x2. Minus 1 square plus minus 1 square 2. 0 by anything is 0. That's why I am not writing here. But here you need to write minus 1 by root 2. Minus 1 by root 2. Again I am saying this root 2 how you got? To find norm x1. If x1 is ABC, norm x1 is root of a square plus b square plus c square. That is formula actually. So like that, root of 0 square minus 1 square plus minus 1 square. What you will get? 2. Like that for this also. 0 square these three terms and add. 0 plus 1 plus 1. 2. 0 by anything 0, no need to write. Minus 1 by root 2, 1 by root 2. So this is the formula you need to remember to find norm x1, norm x1. If x equal to ABC, the norm x can be calculated like this, root of a square plus b square plus c square. If you can remember that one, you can easily write normalized P matrix. Now this is orthogonal matrix. This is the procedure to make a matrix orthogonal. Why we are doing orthogonal P matrix? Because we need to use orthogonal reduction technique. In orthogonal reduction technique, we will make P orthogonal. If you make P orthogonal, then no need to find P inverse. If you can find P transpose, that is enough, that will be equal to P inverse. P transpose means finding transpose of a matrix, already we discussed. Transpose of a matrix is obtained by interchanging row as column. That means first row in P matrix will be first column in P transpose. First column like this. Second row you need to make it second column. 0, minus 1 by root 2, minus 1 by root 2. 1 by root 2. Third row you need to write it as third column. 0, minus 1 by root 2, 1 by root 2. This is P transpose one. Next, we need to calculate P transpose AP matrix. P transpose already we calculated. 1, 0, 0, 0, minus 1 by root 2, minus 1 by root 2, 0, minus 1 by root 2, 1 by root 2. A matrix is given matrix 1, 0, 0, 0, 3, minus 1, 0, minus 1, 3. Next, P matrix normalized P. 1, 0, 0, 0, minus 1 by root 2, minus 1 by root 2, 0, minus 1 by root 2, 1 by root 2. Okay, now if you multiply these three matrices, you will get the diagonal matrix D, that is diagonalization. I said without multiplying these three matrices, already we know what is the answer we are going to get finally. That answer is nothing. In the principal diagonal, you need to keep eigenvalues. Already we calculated eigenvalues. Eigenvalues are 1, 2, 4. So that eigenvalues I am going to keep in the principal diagonal. That will be the answer. For every problem, you can keep eigenvalues in the principal diagonal. No need to multiply these three. If you multiply also, you will get the same thing. But for multiplication, it will take much time. For every problem, diagonalization, diagonal matrix is the matrix which contains eigenvalues as its principal diagonal elements. So this is diagonalization of a matrix by using orthogonal reduction. Orthogonalization. Are you clear, ma?